In the last lecture, we established the fact that physics is a study of material world, and this study is done through experiment. For instance, this boy is wondering, what is the mass of the sack? So he took a weighing scale and put the sack on top of the scale. He was essentially experimenting on the sack. He did a measurement on the mass of the sack and found the mass to be 2.5 kilogram. Obviously, he's very happy since the sack contains money. Who wouldn't? So welcome back. This series of lectures is about physical quantities and units. In particular, this lecture video will touch on the different types of quantities, how they are defined, how they are measured, what it means by 1 meter, for instance. In the previous example, a measurement of mass gives a magnitude, which is 2.5 kg or kilogram. In this regard, direction is irrelevant. It does not make any sense to say 2.5 kg to the left or 27 degrees Celsius upward. Such physical quantity which carry magnitude only is called scalar quantity. On the other hand, in this course we will also be dealing with physical quantities who carry magnitude and direction. For instance, if you are measuring the velocity of a car passing by, say, Air Raja Expressway, you will end up with its speed 40 km an hour, as well as its direction, toward Tuas or East Coast Park, or to the left or to the right. Without both magnitude and direction, your measurement will be incomplete. So be careful. When you are dealing with factors in the exam or test, for example, you are asked to compute the velocity of an object or the amount of force applied, you have to indicate the magnitude as well as direction, unless you are specified otherwise. For example, the question specifically asks for magnitude only, or else your answer will be deemed incomplete. Now let us look at a couple of quantities. We start with these 7 quantities, which are rather unique for a reason I will explain soon. Mass, length, time, temperature, amount of substance, electric current, and luminosity. The units are given in the second column: kilogram, meter, second, Kelvin, mole, ampere, and candela respectively. For the moment, let's ignore the last column on the dimensions. We will come back to that at a later stage. As far as this course is concerned, we will frequently be dealing with the first 5 quantities, namely mass, length, time, and later when we are talking about thermodynamics, temperature, and amount of substance. These 7 quantities are what we call as base quantities. On the other hand, we will also be dealing with what are called as derived quantities. They are called as such because these quantities could be defined with respect to or derived from the basic quantities. Take for example velocity. Velocity is defined as displacement over time. That is to say, how much you have moved divided by how long it takes for you to make that move. Displacement is essentially a quantity describing a length, which is a base quantity. So does time, if you recall the previous slide. So velocity can so-called be derived from 2 base quantities, length and time. As we go through the course, we will learn how other derived quantities such as force, energy, and momentum can be computed from the base quantities. I guess it is quite easy to understand why derived quantities are called as such. But to think about it, we haven't really addressed this question, have we? Why are base quantities are called as such? In what sense the base quantity are basic? Well, it turns out that there are basics in the sense that we, humans, actually came out with standards that define these quantities. Now, what do I mean by that? Take a look at this particular base quantity called mass. This image shows an alloy kept in double-layered glass jar for protection, which serves as primary standard for defining 1 kilogram. In other words, let's say you have a weighing scale at home and you are not sure if your scale is calibrated correctly. That is to say, you are not sure that the object you weigh is exactly 1 kilogram when you do read 1 kilogram on the scale. Then what you need to do is to go look for this standard mass. Of course, to do so, you need to look for the authority, such as the National Institute of Standard and Technology in the US. I don't think we have such standard in Singapore, unfortunately. Anyway, yeah, you need to look for such authority, put the alloy onto your scale, and see if you do read 1 kilogram. If you do not, then you need to recalibrate your scale to ensure that it exactly reads 1 kilogram. Hence, in this sense, mass is a base quantity. It is defined to be such via a known standard. Even more amazing is how scientists or precision engineers define time and length. What is a second? Well, it is defined to be the amount of time taken for a cesium-133 atoms to undergo 9,192,600 and whatever. You can read out that number yourself. In short, a second is defined to be the amount of time it takes for some sort of quantum process to happen this many number of times. You do not need to remember the number. I promise you that this will not come out in the test. Rather, I want you to appreciate how precise a second is defined using modern technology. If you have heard this jargon called atomic clock, this image shows the setup of an atomic clock which helps define what a second is. Another interesting fact is how a meter is defined. Nowadays, precise definition of a meter is the distance traveled by light within 1 over a number which is close to 300 millions of a second. Of course, such measurement requires a machinery no less complicated than an atomic clock. Now, what I want you guys to appreciate here is the fact that a meter is actually defined in reference to a second. That is to say, one should define a second first before defining a meter. But wait a minute, if length is actually derived in inverted comma from time, how could it be a base quantity? Well, remember just now I used the word nowadays? It turns out that historically, a meter was not defined in such a complicated manner. In the same sense as how a kilogram is defined, somebody did come up with a standard 1 meter stick shown in this image. So yes, you may say that the 7 base quantities are called as such due to historical reason. With the progress of knowledge and technology, scientists and engineers are finding more ways to redefine these quantities for a couple of practical reasons. One, an alloy may degrade or oxide over time, and this is of course unacceptable. And two, it is also to make the definition more refined or precise. Now of course, all this doesn't really bother you on daily basis. Your cake will still turn up nicely if you put in 1.01 kilogram of flour instead of 1 kilogram, but it does make a difference when you are doing measurement at the atomic scale. Finally, I would like to close this particular video with a recap of the 7 base quantities. The diagram on the right shows the interdependency of these quantities as defined in modern times. I already told you how length, or a meter, is defined with respect to time, as shown in the direction of the arrow. Based on this diagram, we can see that luminosity and electric current are also defined with respect to time. We can also conclude from this diagram that of all the 7 base quantities, only 3 are truly base quantities, namely temperature, time, and mass. Thank you.